பண்ணிருக்கோம். ஹலோ, ஸ்கூல்ல பிசிக்ஸ் லேப்ல ஏதாவது எக்ஸ்பெரிமெண்ட் பண்ணிருக்கோமா?
எஸ் சார்.
என்ன எக்ஸ்பெரிமெண்ட் பண்ணிருக்கோம்? வீட் ஸ்டோன் பிரிட்ஜ் பண்ணிருக்கோமா?
Yes, sir.
Okay. Now we are in the remote location. Am I correct? I am sitting here. We are sitting here. You people are sitting somewhere far distance. Is it possible to conduct the lab? பண்ண முடியுமா? Are you did any lab in your first semester? பண்ணிருக்கீங்களா? ஹலோ,
ESC, sir.
என்ன லேப் பண்ணீங்க?
EVS.
ஓகே, வேற கம்ப்யூட்டர் பேஸ்ட் லேப் நம்ம என்ன பண்ணோம்?
PLD.
PLD க்கு which platform you use to perform your simulation? என்ன சாஃப்ட்வேர் யூஸ் பண்ணி சிமுலேட் பண்ணீங்க PLD க்கு? ஹலோ ஹலோ, என்ன பேச?
PLD க்கு எது யூஸ் பண்ணல சார்.
PLD க்கு ப்ரோக்ராமிங் எதுல பண்ணீங்க?
Online GDPs.
Yes, that's what I need. So in the same way, to do our electronic devices simulation, we are introducing one online tool that is called Multisim Live. Okay, well, do one thing, go through these procedures, go to this website, then click sign up, then create your own account. So account la inga Alice your name irka, there you need to type your roll number, then your first name and last name, then select the role as a student, then company name. Enna company name kudukalam? You need to give the college name, Karpagam College of Engineering. Okay va? Then your official email ID, then choose any one password, then create your account. Okay va kana? Idu varaiku yarka doubt irukka? Hello?
நோ சார்.
Okay, நீங்க அக்கவுண்ட் கிரியேட் பண்ணிட்டு அப்படின்னா it will ensure to check your account conditional and all. It will give you one confirmation in your account. It will, here you will find your roll number at kc.ac.in. There you need to click. Okay va? இந்த செக் பண்றதுக்கு இன்பாக்ஸ்க்கு ஒரு மெசேஜ் அனுப்பிட்டேன்னு சொல்லணும். இமீடியட்டா யூ கோ டு யுவர் inbox, where you will find one message called please confirm your national instrument user account. என்ன சார் multisim ன்னு சொன்னீங்க, now you are spelling national instrument. So the multisim is the one of the software created by the national instrument. Okay, that is the company name. There you need to click and confirm your mail credential. Once you click it, it will give a thanks message. From there you can start do the simulation. So here I will give you one small task to you people at the end of the session. You need to draw one small circuit. How to draw the circuit means you need to click create circuit, followed by you will get the workspace like this. In this workspace, how you need to start do the diagram. The procedures are clearly given in the PDF file that is attached in your classroom. Is it easy to do this login process, or we need to wait for the next lab class to do this work? Hello? Can the PDF read பண்ணி பண்ண முடியுமா எல்லாத்துனாலே account create பண்றதுக்கு?
Yes, sir.
Only one thing is the important thing. You need to keep remember. You need to use your permanent roll number here. Okay, wow? First give your roll number, then your first name and last name, your role is student, company name is Karpam College of Engineering. If you want to add the address also you can add, then email address, official email ID, password is your choice. Okay, I think you people can follow the Google Classroom works what we are giving. Let me check how many of them have you found. Don't give school address, give the college address. Okay, school name. School name. Yes. Okay.
Full address required.
Record means you browse it in the, it's very simple. Karpam Colleges meaning Coimbatore 32. Okay, ba?
Okay, sir.
Now you please don't do it. Now you come back. This is our classroom activity. Here we will provide number of folders. The very first one, the syllabus. This is also in the PDF format. Please download it and take a printout and paste it in your notebook. Okay. So the syllabus consists of what are all the objectives of this course, what are all the outcomes, module 1, module 2, module 3. Then these are the list of experiment what we are going to carry out. Then these test books are very, very important. Whoever feeling the class is little slow, please get these books. These are all the test books and reference books. We will prefer first 2 test books. Okay. In the test books, I think this test book will be provided by the college. You no need to buy this. If possible, you get this book from your seniors or your elders. Please have a touch with these 2 books. Okay. Then these are all some web URL. This kind of web URLs available in all your syllabus. So since you people are computer science people, browse the content from the net itself and start learn the things little advanced. Okay, this is regarding your syllabus. Then for every class we will post some quizzes. How many of them attended this quiz? Can anyone see and tell me? What is our class strength? What is our class strength? Hello? CSE A la மொத்தம் எவ்வளவு பேர் இருக்கணும்? ஹலோ? CSE A la மொத்தம் எவ்வளவு பேர் இருக்கோம்? ஹலோ? Sajid sir? Hello? Prithvi? Prithvi, am I audible?
Yes, sir.
Okay.
Sir, audible only, sir. Audible only, sir.
Okay, okay. Can I get there are 63 students. Only 7 students were taken the quiz. Remaining students, please try to take before the due date. Don't wait up to the due date because today we will post the second quiz. Consequent classes we will start post the quizzes. So do practice when before coming to the classroom, finish the quiz and come to the class. Okay, then only you can ask and clarify your doubts then and there. Then there are some technical informations, videos also we have posted. Have a look in this. Then the lab record, under the lab record material content, we have posted the PDF file, how to get into the Multisim. Okay. So with this, let me get into the today's class. What are all the content we have studied so far? Can anyone tell me? What are all the content? We have saw in the last class. Last class, with the PN Junction Diode. Very good. Two things we have seen. What is this? Forward biasing and hello? Can you pay some audible doubt? Hello?
Yes, sir, audible.
Yes, sir.
Forward biasing. Forward biasing. Very good. I thought someone will tell we finished reverse bias. We didn't finish the reverse bias. Okay. Let me ask you only one question from this. Answer is also available in the slide. What is the meaning of forward biasing? Can anyone tell me what is the meaning of forward biasing? Hello? With this, we will enter into the today's session. Make it fast. Forward biasing. What is the meaning of forward biasing? Okay, what is biasing? What is biasing?
Application of external work.
Applying.
Providing external energy.
Very good, very good. Applying the external voltage. Very good. Then what is meant by forward biasing? Anode terminal need to be connected to the positive terminal or negative terminal of the battery. Okay. Cathode terminal? Cathode?
Negative
Negative.
terminal.
Okay. That's all. So forward biasing, you need to connect it like this. By the circuit diagram, this is the circuit diagram. Okay. What we will do, we will gradually increase the voltage to find the forward bias characteristics in our laboratory class. Okay. But here only the theory portion we have discussed. Whenever I am giving the input voltage, whether my diode will start conduct immediately or after some voltage range, it will start conduct. After some voltage. What is the name of the voltage? Okay, that is for silicon or germanium? No, that is for silicon. That is for silicon. 0.7 volt. I am asking what is the name of the voltage? Please refer.
Variable.
Threshold voltage or barrier potential. Am I correct? Am I correct?
Yes, sir.
Okay. Okay, Kana, see, this thing gives very clear idea that you people, many of them not taking the class notes. We will ask you to upload your class notes in the Google Classroom. So what is the today's date? What is the today's date? 5/4/2020. Please mark the today's date and start write the content from here. Don't lazy to write the content. Whenever you write something, then only you won't go to the sleep mode. And also your handout is, your class note is very, very easy. Your content to refresh the concepts. Okay, yes. If I give the voltage gradually, what will happen? What will happen? The electrons will get attracted towards the which terminal? Ripples. Electrons will ripple from the cathode. Similarly, the holes will get repelled from the anode. Thereby, my majority carriers cross the junction. Then it creates the current. Therefore, that current name is called what? What? The current name majority current. Why it is called as a majority current? The current flow created because of the majority carriers. Okay. The electron flow will be the opposite direction of your conventional current flow. Your majority current flow is equal to your whole current. Am I correct, sir? Or otherwise, my conventional current flow. Okay. My conventional current flow is always opposite to that of my electron flow. Very clear. Okay. Then majority carrier will contribute the major current flow. At the same time, my minority carriers also crosses my junction. Because of that, there is the second component. What is that? IS. IS mean what? Reverse saturation current. Please make a note of this one. Please make a note of this one. This is reverse saturation current. That means, what is the resultant current flowing in my circuit? So using Kirchhoff's current law, you can come across this equation. The forward diode current IF is equal to I majority minus I saturation. How we arrive this? Please consider this diagram. This is my diode. This is my diode. I have biased with the source like this. So this is the current called the forward biasing current, IF. So IF under current I need to find. So inside semiconductor I have two things. One is I majority. Another one is the I saturation. Am I correct, sir? Am I correct, sir? So as per the Kirchhoff's current law, I can write this equation as the current, the IF is equal to IM minus IS. I'm not getting into the depth in this, why we got the plus minus signs. Whoever understand, please take it as such. Else, please stay back. At the end of the thing, I will elaborately explain this. At this point of time, please take a screenshot of this one. My forward diode current is equal to I majority minus I saturation. Is it clear up to this? Is it clear up to this? Hello? Do you want to explain the concept once again? No need. Okay? Shall I move to the next slide? Shall I move to the next slide?
Yes, sir.
Yes, sir.
Yes. Kana, if you people make me very slow, module 3, you need to study yourself. Okay, that is not possible. Please allow me to take the class in a little accelerated manner. Then only we can cover the content in a given time. Okay, then reverse bias. Any clue what modification I need to do in the reverse bias? Please find the circuit diagram and tell me what changes we made it from the forward biasing to reverse bias. Please tell me.
Anode negative terminal.
Very good, very good, very good. We reversed the polarity of our source. That means anode we have connected to the negative, cathode we have connected to the positive. Can anyone tell me what will be the consequent effect if I give the voltage greater than 0 volt? 0 volt, if it is less than 0 volt, no, nothing will happen. That is equal to no source connected across the PN junction diode. If I increase the voltage a little high, what will happen? What will happen? So the negative source, the negative terminal, this is negative terminal. What is the majority carrier present in the P-type material? What is this majority carrier? Holes. Very good, very good. What is the majority carrier present in the N-type material?
Electrons.
Okay, can you tell me what will happen once I connect the source like this and increase the voltage? What will happen? Holes will get attracted by the negative terminal. Am I correct? Electrons will get attracted by the positive terminal. Am I correct, sir? Am I correct? Yes. Yes. Now you see the animation little. It is getting attracted. Thereby, what happens? What happens? What is the width of the depletion region? Whether it is getting increases or decreases?
Increase.
Increases. Very good. Further, if I increase the voltage, what will happen? Further, if I increase the voltage, what will happen? The depletion region keep on, it will get increased. So due to that phenomena, the majority current flows through the circuit is 0 ampere. Can you correlate with this? Since the depletion region keep on getting increases, there will not be any conduction in this diode. That due to that, the majority current flows through the particular PN junction will be 0. But please observe the consecutive slides. This depletion region having some potential. Due to that increase in potential, your minority carriers will drift. What is the synonym for drift? What is the synonym for drift? What is the synonym for drift? Hello? Hello?
Penetrate.
Penetrate. Very good. Penetrate. It will start penetrate. Please observe, my minority carriers will get penetrate. If this kind of penetration happens, immediately there will be a flow of current. That is called your saturation current. Am I correct? We have seen already in the forward bias, majority carrier contribute pannichina, that current flow is called the majority current. Minority current contribute pannichina, that current is called the saturation current. That too, the current direction is reverse. Thereby, during the reverse bias condition, we will have only the saturation current. Please make a note of this. Here, majority current flow is 0. but the saturation current is a tiny one. Okay, thereby during the reverse bias we will have only Is. So if I take my equation as I reverse bias is equal to ipo enna vandrum I saturation. Is it clear, sir? Is it clear? Can anyone recollect and tell me what is your forward bias current? What is IF? What is IF? I majority
I majority minus
minus
IS.
I saturation. Please compare always like this. I will give you one clue. If you want to have a clear idea about this, at the end of the class, at the evening time, put on tabulation by yourself, serial number, forward bias and reverse bias. Compare the content, whatever things we have discussed so far, make one comparison table. There at the last you can write this equation. Am I correct, sir? Am I correct, sir? Yes. Do have the habit of doing this kind of activities by your own. Okay, then let me discuss the reverse saturation a little deeper. As soon as the minority carrier generate, it swept or drift across the junction because of what? Barrier potential. Barrier potential slowly getting increases, that potential will make this current flow. Okay, so what is the cause of the reverse saturation current? It is your barrier potential. Okay, then current due to the flow of minority carriers remains same. It is not depends on your battery voltage. Please do remember, battery voltage depend body reverse saturation current irukadu. It is purely based on your barrier potential. Okay, then what is the range of this reverse saturation current? The reverse saturation current in terms of nanoampere for silicon, microampere for germanium. Nano na enna sir eludunum? 10 to the power minus
Minus 9.
okay, microampere means 10 to the power.
Minus 6.
What is the meaning of minus 6 and minus 9? 0 point. How many zeros I need to put? 3, 4, 5, 1. Am I correct, sir? If it is minus 6 means I need to mark that much zeros. 5 zeros I need to put. Why? Ingirundu move agudhu. That means I need to subtract one value from here. So 1, 2, 3, 4, 5, 6. Yes, I have reached. Can anyone tell me if it is a nano ampere, how many zeros I need to add after the dot?
8.
8 zeros is the right answer. How that much tiny amount of current flow in my circuit? Whether this current will contribute any useful work? No. Therefore, this current is also called as leakage current. In a current, leakage current. Very tiny amount of current will flow in our circuit. Then the current is very, very small. The number of minority carrier is small. So the rate of generation of minority carrier only depends on your temperature. If you increase the temperature, this current flow will get increased. Can you take a screenshot of this one regarding reverse saturation current? When this reverse saturation current will occur, whether it will occur in the forward bias or reverse bias? Whether it will occur in the forward bias or reverse bias? Dear students, you can answer. Forward bias will occur aguma, reverse bias will occur aguma.
Reverse bias.
Reverse bias will occur. Very good, very good. Now you come back. We will see one more phenomena that is called reverse breakdown. Have you noted down the title? Reverse breakdown. Any guess from this title? Breakdown அப்படின்னா என்னவா இருக்கலாம்? Any idea? Any idea? Hello?
Stop.
Current stop.
Current stop. Okay. Breakdown அப்படின்னா என்ன அர்த்தம்? breakdown. Hello, breakdown அப்படின்னா என்ன? Break ஆகுறது. Okay, we'll see what is breakdown. Okay, see, if I keep on increase the reverse biasing voltage, what will happen? The minority carriers cumulative increase என்ன ஆகும்னா it will the rapid increase in current flow will occur. And the particular stage la enna aiduna diode will get damage. அந்த particular voltage க்கு name தான் வந்து என்னன்னா it is called breakdown voltage. இங்க கரெக்ட்டா எழுதி இருக்காங்களா? VBR. Am I correct, sir? நான் ரொம்ப சிம்பிள். So reverse biasல voltage நம்ம increase பண்ணிட்டே வரோம். ஒரு particular பாத்தீங்கன்னா what they have told, if you are changing your battery voltage, the saturation current change ஆகாது, அப்படி almost constant ஆ தான் இருக்கும். But after some time sudden current increase ஆயிடும். Have you studied this type of graph in your school days? படிச்சிருக்கமா சார்? படிச்சிருக்கமா? அப்ப இந்த வோல்டேஜ்க்கு தான் அவங்க என்ன பேர் சொல்றாங்க? Breakdown voltage. These phenomena we will see in the graph very clearly. Please make a note of this one. Then this voltage will break your crystal structure. Normal application we won't do this. நம்மள்ட்ட ஒரு டயோடு இருக்கு, அதுக்கு வோல்டேஜ் கொடுத்து டேமேஜ் ஆயிடுச்சுன்னு வச்சுக்கோ, அந்த போர்டில் இருக்கிற டயோட நம்ம என்ன பண்ணணும்? we need to replace. நம்ம மொபைல் போன்ல அது மாதிரி ஒரு டயோடு இருந்து டேமேஜ் ஆயிடுச்சுன்னா நீ ரீப்ளேஸ் பண்றதுக்கு நீ அலோவ் பண்ணுவியா? எவ்ரி டைம் அந்த வோல்டேஜ் நம்ம கொடுத்து டேமேஜ் பண்றோம், நீ அலோவ் பண்ணுவியா? ஆர் யூ ஹாப்பி டு சேஞ்ச் யுவர் டயோட் எவ்ரி டைம்? No. Therefore we won't do it this one in the normal applications. Normal application la we won't increase the reverse bias voltage beyond some voltage. That limit is called your breakdown voltage. Okay, then there are two types of breakdown. Have you studied this one? Rendu type of breakdown நம்ம ஸ்கூல்ல படிச்சிருக்கோமா? I will tell you one breakdown, Zener breakdown. Can you recollect what is the second breakdown you have studied? Very good. Who told this answer? Very good, Yogesh. Next one is the avalanche breakdown. These two breakdowns, so based on the input voltage and the phenomena that is named in the two category, that we will see in the Zener diode content. Okay, now we will immediately go to the VI characteristics. What is the meaning of the VI characteristics? What is the meaning of V? What is the meaning of V? Hello?
Voltage.
V is voltage. Okay. What is the meaning for I?
Current.
Very good. Current. VI characteristics அப்படின்னா என்ன இருக்கலாம்? We are going to do an experiment. Then we are going to plot these characteristics. Am I correct, sir? Yes. VI characteristics. அப்ப இது எவ்வளவு டைமென்ஷன் இருக்கு? 2 quantities இருக்கு. அப்ப 2 dimensional graph நம்ம plot பண்ணா போதும். Can anyone tell me in this graph how many axes are available? எத்தனை axes இருக்கு? நம்ம ஸ்கூல்ல வரைஞ்சிருக்கோம் இல்ல, இதுல எத்தனை ஆக்சிஸ் இருக்கும்? எத்தனை ஆக்சிஸ்? வெரி குட். x axis and y axis. ஓகே, x axisல என்ன குவாண்டிட்டி மார்க் பண்ணணும், y axisல என்ன குவாண்டிட்டி மார்க் பண்ணணும்? Can everyone please wear your headphone and listen this basic thing. This is a very fundamental for your engineering. x axisல என்ன குவாண்டிட்டி மார்க் பண்ணணும்? Dependent quantity or independent quantity? நம்ம 6th ஸ்டாண்டர்ட்ல படிச்சிருப்போம். Independent or dependent? Independent. Can anyone tell me can anyone tell me speed versus time graph வரையறோம். இதுல எது independent quantity, எது dependent quantity? Speed versus time. எது நம்மளால ஸ்டாப் பண்ண முடியாது, அது பாட்டுக்கு போயிட்டே இருக்கும்? டைம். அப்ப டைம் எந்த ஆக்சிஸ்ல வரணும்? டைம் எந்த ஆக்சிஸ்ல வரணும்?
X.
Speed எந்த ஆக்சிஸ்ல டிராப் பண்ணணும்? Y axis. So with respect to time, I attain this much speed. இப்படிதான் நம்ம graph plot பண்ணுவோம். So this is the very fundamental thing you need to remember in our electronic devices or electrical circuits. In all the sciences, we are following the same thing. When you are going to apply the voltage, so by changing the input voltage, I am going to take the current flowing through the circuit. That means the input voltage V is a independent quantity. Therefore, I need to take it in the x-axis. What is the dependent quantity, madam? What is the dependent quantity, madam and sir? Current. So I need to mark it in the y-axis. Are you happy with this? The term what you have studied, we have recollected. இதுக்கப்புறம் உனக்கு சர்க்யூட் கொடுத்தா எக்ஸ் ஆக்சில் எது வரையணும், y ஆக்சில் எது வரையணும் டவுட் வரக்கூடாது. Is it clear, sir? Is it clear? Yes. If you refer some standard textbooks, they will write it as a IV characteristics. So always they will take the y-axis quantity first, then the x-axis quantity second. So it is the very standard one, but unfortunately we start using this notation. Please follow the same thing, but you don't get confused. Somewhere in your textbooks it is written as IV characteristics. It is very much similar to your VA characteristics. Okay? Yes. So IV characteristics la enna sir panna porom? We are going to obtain the graph, we are going to apply the voltage. So there are two characteristics. I am not going to discuss in detail because this is the very first experiment we are going to do in the laboratory. Therefore, I will tell you the brief things what we are going to do. We are going to connect the battery like this. How to find the current through the circuit? How to find the current through the circuit? In the meter use panning a current measure pandrom. Any idea? Any idea? Ammeter. How to measure the voltage across the diode? How to measure the voltage? In the meter use pananum?
Voltmeter.
That's all. Another symbols are very simple. Put a circle and write the quantity what you are going to measure. Then put two terminals and wait for some time, whether it is a DC quantity or AC quantity. DC. Straight line. If it is the AC, how to mark the voltmeter? Put a sinusoidal wave symbol. Is it clear, sir? Is it clear, sir? This is DC voltmeter. This is AC voltmeter. Already you have studied. This is your moving coil instrument. This is your moving ion instrument. Sorry. I'm sorry. This is your moving coil. This is your moving ion. Okay. Then ammeter na penna change. What we need to do, sir? Put a circle. Put capital letter A. Put two leads. Then, if it is a DC ammeter, what I need to do? Put straight line. If it is a AC ammeter, what I need to do? AC ammeter. Put a sinusoid. Is it clear, sir? Is it clear? Is it clear so far? Hello?
Yes.
Yes. So IV characteristics pandradhukku we have introduced one resistor that I will teach you in the laboratory class. Don't worry. Here you need to take away one more point. Always voltmeter need to be connect across the element or parallel. அப்ப ammeter எப்படி connect பண்ணனும்? Series. Please note down these two hints.
Series.
Remaining we will teach you in the lab session. Okay? Yes. Please take the screenshot of this one and come back here. So now we are gradually, it is unbiased condition. Therefore, my current through the circuit and voltage starts from the origin 0, 0, 0. Now gradually I am going to increase the voltage. Okay, gradually I am going to increase the voltage. Now my input voltage is 0.2 volt. It may not visible to you people. Let me write here. I have a 0.2 volt கொடுத்திருக்கேன். 0.2 volt கொடுக்கும்போது இதுல some voltage drop ஆயிருச்சு. Remaining voltage மட்டும் எனக்கு டயோடுக்கு அக்ராஸ் இருக்கிறத மட்டும் நான் மெஷர் பண்ணனா it is 0.1 volt. Can you see the reading? Second dot. Current என்னவா இருக்கு sir? Current என்னவா இருக்கு? Still it is current, it is still it is 0.
0.
Shall I increase the voltage little bit? Little bit. Now I have given 0.4 volt கொடுத்திருக்கேன். டயோடு அக்ராஸா எவ்வளவு வோல்டேஜ் இருக்கு சார்? டயோடு அக்ராஸா எவ்வளவு வோல்டேஜ் இருக்குது? Whether we are having current through the circuit still? No, still it is 0. Still I am increasing the voltage to 0.3, 0.4, 0.5, 0.6. Now I am closely touching 0.7. Before 0.7, slight increase in current. Can you zoom and check this increase in current? Mobile phone zoom பண்ணி பாரு, increase ஆயிருக்கா பாரு current?
Yes, sir.
Increase ஆயிருக்கா sir? Increase ஆயிருக்கா? Further I am increasing the voltage. What happens to the current, sir? What happens to the current?
Increasing.
Increases. This point where the current suddenly starts increasing, that voltage is called, நம்ம காலை இப்படி மடக்கி வச்சோம்னா இப்படி இருக்கும். இந்த போர்ஷனுக்கு என்ன பேரு? நீ கரெக்டா? அதுக்கு அப்படியே இன்வெர்ட்டடா இந்த வேவ் ஃபார்ம் இருக்கா, இப்படி இன்க்ரீஸ் ஆகுது. அப்ப இந்த வோல்டேஜ்க்கு என்ன பேர் வச்சிட்டாங்க சயின்டிஸ்ட்?
Knee voltage.
How clever they are, how simplified the concept. Physics professorக்குலாம் நம்ம தேங்க்ஸ் சொல்லணும். Am I correct? நீ இதையுமே மொட்டை மனப்பாடம் பண்ணாத, அண்டர்ஸ்டாண்ட் பண்ணு, கம்பேர் வித் த நேச்சர். நேச்சர்ல இருக்கிற பேரு தான் நாங்க இங்க சயின்டிபிக்கா வச்சிருக்கோம்னு சொல்றாங்க. Okay, yes, this knee voltage have many alternate names. Shall we note down that one? What is the other name of the knee voltage? Can anyone tell me? Cut-in voltage. Okay, hello. Other name of the knee voltage is called cut-in voltage. Okay, V, இது என்ன symbol கண்ணா? Alpha, beta or gamma? Gamma symbol. Okay, yes. So your knee voltage is also called as the cut-in voltage. After some cut-in voltage, it will start conduct. Now the current through the circuit is equal to what? IF is equal to what? Can anyone tell me? Watt minus what? IF is equal. Very good. I majority minus I saturation. The same experiment we will do it in the multisim. If possible, after did your login in your live multisim, try to do the same circuit by your own and come back. Okay, tomorrow is a holiday. You people can do it by yourself. Okay, here don't get confused with the input voltage and voltage across the diode. Okay, nama graph plot பண்றது, do remember one thing, it is voltage drop across the diode only. That means this voltmeter reading and ammeter reading, not the input voltage. Okay sir, am I clear with this? Yes. Now then இது எந்த cut-in voltage க்கு அப்புறம் நமக்கு வந்துச்சு? 0.7 க்கு அப்புறம் வருது. If it is a silicon, it's a germanium, where my graph will fall? Can anyone assist me?
0.3.
0.3 க்கு அப்புறம் இப்படி போகும். Am I clear sir?
Yes.
We can mark this also, no issue. Mark it. This is for germanium, this is for silicon. Consider I am having same silicon diode, same input voltage, if I am increasing the temperature, எதை increase பண்றோம்? Temperature increase பண்ணா graph before வருமா இல்ல after வருமா? Whether I will get option A or option B if I increase the temperature.
Before.
Option
Before,
A.
option A is the right answer. If I increase the temperature, my cut-in voltage will fall little before. If I increase still high, so I can vary my cut-in voltage based on the material used as well as the temperature. And also one more thing is your doping level. Am I clear, sir? Yes. Then reverse bias. Reverse bias la enna panna porom, sir? Very simple. Reverse the battery symbol. Correct, sir? Reverse the polarity of your battery and do the same exercise. Same exercise. Reverse la pannamna enna agum? Konjam konjama increase aite varum. After some time enna nadakkum, sir? After some time, please note down the voltage level. These are all not 1 volt or 2 volt. 200, 800, 1000, 1200. That means 1.2 kilovolt. Correct, sir? This much high voltage is not possible to do in the practical laboratory session. But in your simulation lab, we can do this. So increase point around. Beyond some voltage, current increases. Can anyone tell me what is this point? The point நம்ம என்னன்னு படிச்சோம், just now we have studied. What is this point called?
knee voltage. Knee voltage.
No, it is not. Okay, இது வந்து reverse knee voltage னு வெச்சுக்கலாம், but இதுக்கு இன்னொரு பேர் இருக்குது.
Voltage breakdown.
Yes, breakdown voltage. கண்ணா நீ டெக்னிக் புரிஞ்சுக்கிட்ட, voltage first pronounce பண்ணக்கூடாது. First pronounce the subscript, then this one. அப்ப எப்படி படிப்பே சொல்லு? Breakdown voltage. கண்ணா this is not zero. நீ கொஞ்சம் பாத்தீங்கன்னா ஒரு சின்ன கேப் இருக்கும். நம்ம டெக்ஸ்ட் புக்ல பார்த்தா எப்படி டிரா பண்ணிருப்பாங்கன்னா இப்படி டிரா பண்ணிருப்பாங்க. Even in your school days you may study this graph. Okay, this is not zero. அப்ப இந்த கரண்ட்க்கு என்ன பேர் நம்ம படிச்சோம்? இந்த கரண்ட்க்கு என்ன பேர் படிச்சோம்? Reverse bias la vara solli tiny amount of current is your saturation current. Am I clear, sir? Yes. So with this please take a screenshot of this one. PN junction diode will get damaged at the breakdown. அப்ப நம்ம we won't encourage this. அப்ப ஒரு லிமிட் இருக்கும்ல, இந்த லிமிட்டுக்கு மேல போக கூடாதுன்னு சொல்லுவாங்கல்ல. அப்ப அதுக்கு ஒரு பேர் வச்சிருக்காங்க the manufacturers. That is called peak inverse voltage. Can you see the sentence present at the bottom of your slide? PIV. In short, it is called as PIV. That is known as the maximum reverse voltage that can be applied. Please note down. That can be applied across the PN junction diode without breakdown is known as peak inverse voltage. Peak inverse voltage will be greater than or less than your breakdown voltage. எப்படி இருக்கும்? Peak inverse voltage greater இருக்குமா இல்ல lesser இருக்குமா இல்ல equal இருக்குமா?
Less.
Very good. Who will give you this information? Manufacturer. Who will give this information? Manufacturer will give this information. Yes, sir? Yes, sir? Any doubt?
No, sir.
Hello, sir? Hello, sir? Shall I continue? Shall I continue? அப்ப டயோடு பிரேக் ஆகாம இருக்கிறதுக்கு இதுக்கு முன்னாடி ஒரு ஸ்பெசிஃபிகேஷன் கொடுப்பாங்க. lesser than your breakdown voltage that will be provided by the manufacturer. I will show you one data sheet in the lab class. Don't worry. Now your task is to combine these two characteristics, both forward and reverse bias. Please take your class note and combine these two characteristics. How you will draw? X-axis, origin, what is this? current flow through the circuit. So this is current. IF is the forward current. This is forward voltage. This is my reverse voltage. If you plot the graph, please take some scales. So up to இது வரும்போது 0.7 இருந்துச்சுன்னா, sorry, 0.7, this is your forward bias. Then reverse current. So this is my saturation current, tiny current. After that, what is this point is called? BR, VBR. What is this point is called? Knee point or cut-in voltage. Have you noted down these things in your class note? Combined graph of your forward bias and reverse bias. Forward bias என்ன quadrantல வந்திருக்குது? First quadrant, second quadrant, third quadrant or fourth quadrant? Forward bias.
First quadrant.
Okay. Reverse bias?
Third quadrant.
Third quadrant.
Very good. அப்ப மேக்ஸ்ல எதுக்கு first quadrant, second quadrant teach பண்ணாங்கன்னு இப்ப நமக்கு தெரியுதா சார்? தெரியுதா? Yes. Have you noted down this in your notebook? Please note down, don't note down this quadrant and all. Please draw this graph now. Here this is reverse bias. Is it clear? Is it clear? Hello? And if you say yes, I will continue.
Yes, sir. Audible, sir. Yes, sir.
Audible, okay. Have you drawn this characteristics?
Yes, sir. Yes, sir.
Combine the characteristics in your notebook. I hope my students definitely they will draw. Now we will come to the one more little title. Kana idu varaikkum padichadhu basic things nama school la padichadhu. Idukapram da nama college kulle enter. அப்ப நம்ம காலேஜுக்குள்ள என்டர் ஆகிறதுக்கே 4 கிளாஸ் ஆயிடுச்சு. கரெக்டா கண்ணா? ஸோ இதுக்கப்புறம் காலேஜ்னாலே கொஞ்சம் லிட்டில் தியரி இருக்கும், ஈக்குவேஷன்ஸ் இருக்கும். Everyone please start write these new content in your notebook. Don't afraid. Okay? Yes. Static and dynamic resistance. Resistance can a symbol, sir? Capital R. What is the meaning of static and dynamic? Bus stand la nikkudu. Then adu move aite irukku. Rendu phenomena. Bus stand la irukumbodhu enna state, road la run agumbodhu enna state. Which one is static, which one is dynamic?
Bus stand la be static, sir.
Bus stand la irundhathu static. Okay. Appa run aite irukumbodhu irukkiradhu
Dynamic.
These two things already you have studied in your school days. Static na theriyum, dynamic na theriyum. So what is related to our PN junction diode? Static na enna, dynamic na enna? Very simple. We will say one by one. The very first one, static or DC resistance. Are you got the answer now? Are you got the answer in this title itself? What is the meaning of static resistance in the VA characteristics? That's all. When if you apply the DC voltage, at the time if you find the resistance of the diode, it is called static resistance. Can anyone tell me what may be the dynamic resistance? AC voltage. It's very good. And I will simpler class listen panna, you don't need to study at all. Okay, class notes mattum நம்ம ரிவைஸ் பண்ணி quiz attend பண்ணிட்டு போயிட்டே இருக்கலாம். ஓகேவா? Now I will ask you one thing. இந்த ரெசிஸ்டன்ஸ் நம்ம கிராஃப் 2 குவாட்ரண்ட்ல வரைஞ்சோம். அப்ப ரெசிஸ்டன்ஸ் எந்த 2 குவாட்ரண்ட்ல மெஷர் பண்ணுவோம்? Right. First and third. Kana second and 4 is empty. Who told that answer? Please correct it yourself. இங்க ஒண்ணுமே இல்ல. இதுல எப்படி போய் நம்ம ரெசிஸ்டன்ஸ் மெஷர் பண்ண முடியும்? மெஷர் பண்ண முடியாது இல்ல? Yes. This kind of experiment already we have did in our school days. You no need to bother or you no need to surprise what we are doing here. I drawn one small circuit in front of you. Can anyone tell me what experiment is this? What experiment is this? What experiment is this?
Ohm's law.
Ohm's law. Have you did the characteristics like this? Am I correct, sir?
Yes, sir.
What is this graph again? What is this graph again? We get a 6 of a resistor. Resistor. Am I correct? Am I correct? Am I correct?
Yes, sir. Yes, sir.
Okay. Ohm's law said a few things. I is directly, V is directly proportional to I. Now I is directly proportional to V. இது மாதிரி ரெண்டு டேர்ம்ல ஸ்கூல்ல படிச்சிருக்கோம். கரெக்ட்டா? அதுக்கப்புறம் we derived some equation. I equal to V by R. Okay. V is equal to
I into R.
R equal to what?
V by I.
V by I.
If I want to find the value of the resistance, say example, here I am having 10 volt. I will draw one line. Then I will proceed the same line in the x-axis. Maybe the current is 2 ampere. What is the value of the resistance? Can anyone tell me?
5 ohm.
How you arrived 5 ohm? V by I. That means 10 divided by 2 is equal to 5 ohm. But we won't take a single value sometime. We will take number of readings. The small, what is the meaning of slope? What is the meaning of slope? What is the meaning of slope? Slanting, correct? Slanting angle, correct? Slope நம்ம படிச்சிருக்கோமா?
Yes, sir.
ஆனா டிரைவ் பண்ணும்போது சொல்லுவேன் இப்படி இருக்குது, இது கொஞ்சம் மேல போகணும். அப்ப நீ என்ன சொல்லுவேன்? ஸ்லோப் எப்படி இருக்கு? ஸ்லோப் இது எப்படி இருக்கு? செகண்ட் இது எப்படி இருக்கு? ஏ எப்படி இருக்கு கம்பேரிட் டு பி? ஸ்லோப் அதிகமா இருக்கா கம்மியா இருக்கா?
அதிகமா இருக்கு.
அதிகமா இருக்கு. இப்படி இருந்தா ஸ்லோப் எப்படி இருக்கு?
கம்மியா இருக்கு.
அப்ப மேத்தமெட்டிக்ஸ்ல we know one thing. If I find how to find the slope, you know. Am I correct? Small change in, can anyone tell me what is the formula to find the slope? Slope is equal to small change in value in which axis divided by which axis? Y axis divided by X axis. The same way, what quantity present over here in the Y axis? Current. Delta I divided by delta V. Am I correct? Am I correct?
Yes, sir.
If you take an inverse of this, what you will get? You will get resistance value. Is it clear, sir? Already you have studied this concept. Don't worry, don't bother about this. Just take a screenshot of this one and correlate the things what you have studied so far with that idea. Without making much delay, we will enter into the static resistance of your diode during forward bias as well as the reverse bias. Okay. Shall we see the for forward static resistance? Yes. Forward static resistance is nothing but RD. Can anyone tell me how to find the RD from the thing what we have discussed so far? The hint VF1 and IF1. What is the formula to find the RD value? R is equal to what?
V by I. This is called dual motion
VF1 divided by IF1. Hello. Can I please mute yourself? Somebody is talking with someone else. Hello? Is it clear, sir? Are we arrived the equation? How to find the static or DC resistance during forward bias? Hello? Shall we check our answer?
Yes, sir.
Yes, it's correct. Am I correct, sir? What we arrived is the right one. Correct?
Yes, sir.
Very good. Very good. Please take a screenshot of this one. Next one. Next one. Reverse bias. Reverse bias, again I am going to measure the RD value. Can anyone make an attempt? So far not interacted, please interact. What is the formula to find RD from the point B? P use பண்ணி நீ சொல்லணும். Please make an attempt. May call the birthday baby. Kana 20p 158. Kana Udaya Rajan. Many more happy returns of the day.
Thank you, sir.
Thank you very much. Thank you. Thank you. Hello. என்னடா ஒரு ரியாக்ஷனே காண கிளாஸ்ல ஒருத்தனுக்கு பர்த்டேக்கு விஷ் பண்ணா ஒரு ரியாக்ஷனையுமே காண கிளாஸ் ரூம்ல
ஆல்ரெடி விஷ் பண்ணியாச்சு சார்.
ஆல்ரெடி விஷ் பண்ணதுனால எல்லாம் சர்ப்ரைஸ் இல்ல. ஓகே, நோ இஷ்யூஸ். ஓகே, can anyone make an attempt? What is the value of RD?
VR1 by IR1.
That's all. VR1 divided by IR1. Shall we check our answer? Shall we check our answer? Yes. Is it right? Is it right? Here they written as a RR. Don't get confused. The reverse bias nala they have marked like this. Simply you put it as a RD. Don't worry. VR1 divided by IR1. So என்ன இப்ப என்ன ரெசிஸ்டன்ஸ் பார்த்திருக்கோம் இது வரைக்கும்? ஸ்டாட்டிக் ரெசிஸ்டன்ஸ் பார்த்திருக்கோமா, டைனமிக் ரெசிஸ்டன்ஸ் பார்த்திருக்கோமா?
Static.
Static. Shall we see the dynamic resistance?
Okay. Yes, sir.
Dynamic resistance or AC resistance or D. Okay. Again, இதுல எத்தனை values இருக்கும்? How many resistance values we need to find? Forward bias and reverse bias. Okay va? So AC voltage apply பண்ணும்போது what என்ன characteristics வரும்ன்றதை we need to find, but here it is not a single operating point. Here you need to find the slope. Why? Listen, please observe here. In my circuit, if it is a DC circuit, I may operate my mobile phone with the operating voltage of 3.3 volt. Or 3.3 volt la da operate agum. But think about your AC circuits. AC circuit doesn't have a single value because of the nature of the input voltage. What is the shape of this waveform? What is the name of this waveform? Can anyone tell me? Sinusoidal. Change in voltage with respect to time. Variety irukka or quantity here. We need to attack in the same fashion. Therefore, I am going to find the slope. Slope means what? The ratio between the small change in value to the small change in value. That means I am going to find the change in voltage divided by the result of change in current. That means del V divided by del I. Is it clear, sir? So in the del V and del I portion, enga sir kandupidicha? Very simple. Very simple. Take these 2 points and I am going to magnify this portion. I am going to magnify this portion. So consider this is this portion. This is the portion where I am going to apply my AC voltage. புரிஞ்சிருச்சா சார்? ஏன் இந்த change in voltage? Positive peak, negative peak. On the particular input voltage, what is the change in current? I no need to magnify because I am having a little bigger scale. If I give this sinusoidal input, this will be the current. I can't take the single point. Therefore, I am going to take the small change in voltage to the small change in current. Okay? Can anyone tell me, without making much delay, how to find RD? RD is equal to what?
Delta VF by delta I.
Del VF by del IF.
That's all. That's all, Your Honor. Please make a note of this one. Please make a note of this one. Let me check the answer. Yes, it's right. or D is equal to del VF divided by del IF. Then the reverse bias condition. Reverse bias condition in okay, let me do one calculation. Try பண்ணலாமா? Yes. இது இப்பதான் இன்ஜினியரிங் குள்ளே வந்திருக்கும். How many of them having calculator in your hand? Casio 991 ms. 991 ms is the calculator allowed to use in the engineering studies. Okay, what is the brand name? Casio FX 991 ms. Are you having this calculator in your hand or in your home? If not, get it in the consecutive classes. எங்கயாவது நம்ம சால்வ் பண்ணும்போது இதை யூஸ் பண்ணி தான் பண்ணணும். ஓகேவா? எஸ் 991 ES நான் இங்க நேம் மாறிடுச்சு. அப்ப ஏதாவது கொஞ்சம் இம்ப்ரூவ் பண்ணிருப்பாங்க. Programmable thing skills in your particular calculator is improved. Therefore, during examination, they won't allow. But at this point of time, you can use it, no issue. Okay? Exam hall kulla mattum allow panna mattaanga. Okay va? Yes. Please take the question. Don't consider this as a problem. The problem mind la eduthittina it will give you a big problem. Okay va? Ida problem ah eduthukada maybe question number 1 nu vechiko. Okay va? First question, determine the DC resistance for the PN junction diode from the VA characteristic shown in the figure. Many of the time while you will be attending the objective questions, இது மாதிரி ஒரு question இருக்கும், diagram இருக்காது. அப்ப என்ன அர்த்தம்? Some missing data. கரெக்டா? Or else உன்னோட Google form இன்னும் load ஆகலன்னு அர்த்தம். Am I correct, sir? Am I correct and clear? கொஞ்சம் நீ திரும்ப login பண்ணி check பண்ணி பார்க்கணும். Now are you got the waveform now? Are you get the waveform now? Kadachcha sir? Yes. Shall we start do the calculation? What they have asked? Determine DC resistance. DC resistance means it is a static resistance or dynamic resistance?
Static.
Static. What is the formula to find? RD, capital RD is equal to what? Formula மட்டும் சொல்லுங்க. RD is equal to F divided by IF. Am I correct?
Yes, sir.
Okay. Now here they given two conditions. ID is equal to 200 milliampere. Here it is given. Yes, it is given over here. This is the first given data. First, I need to calculate for this option. Okay. What is the voltage related to this 200 milliampere? Can anyone tell me? இதுக்கு related ஆன voltage
0.85. Summation is
0.85 is the correct answer. Please substitute in your equation, please. Point. நான் ரொம்ப நாள் கழிச்சு calculate பண்றேன் நினைக்கிறேன். தப்பு இல்லாம சொல்லணும். 0.85 divided by 200 milliampere. How to write this? Am I correct, sir? Am I correct, sir? Or else 0.85 divided by எத்தனை ஜீரோ போடணும் இந்த டாட்க்கு அப்புறம்? இங்க 3 இருக்கு, அப்ப எத்தனை ஜீரோ போடணும்?
2.
Okay, find the answer and tell me. Make it fast. கொஞ்சம் குயிக்கா கண்ணா. What is RD?
423.
How much you are getting? RD. Hello? Can you type your answer in the chat box, please? Hello, madam.
425.
420. Okay, let me check. 0.85 divided by
425.
20 milliampere. 0.85 தானே? Yes, 0.85 divided by 20. எவ்வளோ சார் வருது ஆன்சர்?
425 sir.
425.
That's all sir.
That's all. Okay. 425. சின்ன mistake வருது. சரி, okay, we check the answer. 42.5 வருது சார். என்ன தப்பு பண்ணோம்? Can anyone watch my camera? Can anyone watch my camera?
Yes, sir.
நான் எப்படி டைப் பண்ணியிருக்கேன் பாருங்க. 0.85 divided by என்ன போட்டிருக்கேன்?
Sir, கொஞ்சம் blur ஆ இருக்கு sir.
இப்ப பாருங்க, தெரியுதா?
Yes, sir.
I have typed as 0.85 divided by 20 followed by small m. இது எங்க சார் இருக்கு நம்ம கால்குலேட்டர்ல? shift 5 press பண்ணுங்க பார்க்கலாம். What you are getting? Are you getting small m in your calculator now?
Yes sir.
Now you tell me your answer without any mistake.
42.5 sir.
42.5 ohm is the right answer. Don't make any silly mistakes like this. Okay, nothing wrong, Kana, nothing wrong. You will find easy to do this calculation once you practice. Now we will come to the option B. Option B, what they have given, VD is equal to minus 10 volt. Where it is available? Here. Am I correct, sir? What is the current related to this voltage? Trace this point. What is this? How much it is?
-2.
Minus 20 microampere. Am I correct?
Yes sir.
Take your calculator. Minus 10 divided by minus 20 into 10 to the power minus 6. Write it like this and take your calculator. I will write you the calculator step in green color. Take your calculator. Minus minus actually it will get cancelled. So simply put 10 divided by 20. Can anyone tell me how to get this micro symbol from our calculator? Shift plus what? Shift plus what? Quick. Hello? Am I audible?
Yes.
Yes, sir.
Where you will find this micro symbol in your calculator? நிறைய பேருக்கு இருக்காது. Sorry. Okay, let me show. If you press shift plus 4, you will get the micro symbol. Okay, va? So 10 divided by 20 micro. So who are having calculator, please solve and show your answer to your friends. Camera on பண்ணி காட்டினா உங்க friends பார்ப்பாங்க. என்ன ஆன்சர் வந்திருக்கு? என் டிஸ்ப்ளே பார்த்து ஆன்சர் சொல்ல முடியுமா? How much you are getting?
5 lakhs.
5 lakh ohm. இதை எப்படி சார் இன்ஜினியரிங் டேர்ம்ல சொல்றது? 500 into 10 to the power 3 ohm ன்னு சொல்லலாமா? That is equal to what? 500 kilo ohm. Am I clear, sir? Am I clear? That's all. Please take a screenshot of this one. I know you know why you need to get the scientific calculator. Am I correct? Manually நீ solve பண்ணி போட்டாலும் within a step you can do it. இது மாதிரி calculations எல்லாம் practice. Okay, yes. Now, second question. Observe the diagram and tell me the answer. Determine whether the diode D is forward biased or reverse biased. Make it first. Forward biased or reverse biased? What is the potential at this anode terminal? 0 or some value? 0. Okay. What is this terminal? Cathode. The cathode இருந்து இங்க பார்த்தோம்னா some voltage 10 volt இருக்கு. கரெக்ட்டா?
Yes, sir.
Can anyone tell me whether my diode is forward biased or reverse biased? Let me redraw the diagram. The diagram பார்க்கிறதுக்கு ரொம்ப கஷ்டமா இருந்துச்சுல்ல? Don't surprise. This is the equivalent diagram. Now you tell me what biasing it is.
Reverse.
அவ்வளவுதான். That is the answer. கொஞ்சம் இந்த கிரவுண்ட் சிம்பிள் வந்துச்சுன்னா அது என்னன்னு கன்சிடர் பண்ணிக்கலாம்? நெகட்டிவ் டெர்மினல் கன்சிடர் பண்ணிக்கலாம். அப்ப இங்க +10 இருந்தா என்னன்னு கன்சிடர் பண்ணிக்கலாம்? பாசிட்டிவ் பிளேட் ஆஃப் தி சோர்ஸ்னு கன்சிடர் பண்ணிக்கலாம். Is it clear, sir? Is it clear? Yes. Let me draw one more thing and ask the question. Whether it is forward biased or reverse biased. Why it is reverse biased? Okay, but it is very good. Kana very simple. VAK, anode to cathode voltage. AK இதை நம்ம எப்படி எழுதணும்னா VA minus VK. What is VA? 5 volt. What is VK? 10 volt. What is the difference? Sorry, 15. What is the difference? Minus 10 volt. Minus nu vanditale adu enna bias?
Reverse.
That's all. Okay, let me ask the last question. What biasing it is?
Forward bias.
That's all. Please make a note of this. This is forward bias. This is reverse bias. This is also all the things at the right hand side is reverse bias. Left hand side only one diagram is forward bias. So this is equivalent to this diagram. புரியுதா சார்? கொஞ்சம் எலக்ட்ரிக்கல் சயின்ஸ் புரிய ஆரம்பிக்குதா? கிளாஸ் கவனிச்சுட்டே இருந்தோம்னா புரிய ஆரம்பிக்கும் ஸ்லோவா. எஸ். Let me go to the next question. Answer is the reverse bias condition. Okay, va? Yes. Next. Find the voltage between A and B below figure. Consider diodes are forward biased. Biased na enna meaning? Conduct ஆயிருச்சு. கரெக்டா? Forward bias ஆயிருச்சு. அப்ப question number 3, can anyone tell me? Before that, if you have any doubt, please wait. Let me recollect one useful law you have studied in your school days. What is the voltage across this resistor? What is voltage across this resistor? 5 volt. That means what? The sum of potential drop is equal to sum of potential rise. This is law idu? Kirchhoff's voltage law. With this idea, can anyone tell me what is the voltage between A and B? அப்படினு என்ன கேட்டிருக்காங்க? VAB கேக்குறாங்க. கரெக்ட்டா? இப்ப இதுல என்ன வோல்டேஜ் இருக்கும்? இதுல என்ன வோல்டேஜ் இருக்கும்? What is the cut-in voltage of silicon? That is the clue.
0.7.
What is the cut-in voltage of germanium?
0.3.
Now, without making much delay, tell me what is the voltage between the terminals A and B? 1 volt is there. Engineering புரிய ஆரம்பிக்குதா? டஃப் எல்லாம் கிடையாது. இதுக்கு முன்னாடி இருந்து ரிகலெக்ட் பண்ணோம்னா ஒர்க் ஆயிடும். ஸ்கூல் டேஸ்ல படிச்ச KVL இங்க வந்து யூஸ் ஆகுது. நம்ம யோசிச்சு பார்த்திருப்போமா இது மாதிரி யூஸ் ஆகும்னு? Okay, please take a screenshot of this one. Yes. Okay. Shall I move to the next question? Next question illa. Hello? Hello?
Yes, sir.
Yes, sir.
Yes. If I put the diode like this, என்ன ஆகும்? இது என்ன biasing?
Forward.
இது என்ன biasing? Okay, very good. Very good. Next title. Ideal diode. Note பண்ணிக்க பார்க்கலாம். Ideal diode. What is the meaning of ideal? What is the meaning of ideal? Or what is the synonym for ideal? Hello? Ideal உட்கார்ந்திருக்க கூடாது, ஆன்சர் சொல்லணும். ஹலோ, நீ இப்போ உட்கார்ந்திருக்கிறது ஐடியல், கரெக்டா?
தனித்து விடப்பட்டது.
தனித்து விடப்பட்டது. வெரி குட். ஆனா நீங்க எந்த ஸ்கூல்ல படிச்சீங்க?
கோபால் ஆயிடுச்சு.
கோயம்புத்தூர்ல?
எஸ் சார்.
ஓகே ஓகே, நீ நான் உன்னை அப்புறம் கேட்ச் பண்றேன். உங்க நேம் என்ன?
ஸ்ரீஹரி.
திருப்பதியா?
ஸ்ரீஹரி.
ஸ்ரீ
ஹரி.
ஸ்ரீஹரி. ஓகே ஓகே, நான் அப்புறம் பிடிக்கிறேன் ஒன்று. ஐடியல் டயோடு, ஓகேவா? ஸோ ஐடியல் கண்டிஷன் அப்படின்னு நம்ம சொல்லுவோம். ப்ராக்டிக்கல் கண்டிஷன், ஐடியல் கண்டிஷன். ரொம்ப சிம்பிளா சொல்லட்டுமா? The election commission expects this. But what will be the practical one? What is the practical one?
Less than 100.
Less than 100. Is it clear, sir? Is it clear? So, இப்போ ஐடியல் கேஸ் அப்படின்னா இதுக்கு இன்னொரு நேம் இருக்கு, தியரிட்டிக்கல் கண்டிஷன். அஷ்யூம், நம்ம தியரிட்டிக்கலா இப்படி இருக்குன்னு பார்த்துக்கலாம். பட் ப்ராக்டிக்கல்ல based on some criteria it will vary. Am I clear, sir? So in the same way ஐடியல் டயோடு அப்படின்னு எடுத்துட்டோம்னா அதுக்கு சம் கேரக்டரிஸ்டிக்ஸ் இருக்கு. ஓகேவா? நம்ம டயோடுக்கு நம்ம இப்போ இதுக்கு முன்னாடி பார்த்த கிராஃப் எல்லாம் ப்ராக்டிக்கல் கிராஃப், இப்போ ஒரு ஐடியல் கிராஃப் பார்க்கலாம். ஓகேவா? ஸோ ஐடியல்ல we need to assume something. என்னெல்லாம் அஷ்யூம் பண்றோம்? ப்ளீஸ் மேக் நோட் ஆஃப் திஸ் ஒன். Zero resistance and also it is a closed circuit. First assumption. Second assumption, can anyone read it by unmuting your mic, please? What is the second assumption? What is the second assumption? Hello? Hello? What is your second assumption?
Zero forward voltage drop.
Zero forward voltage drop. அப்படின்னா என்ன மீனிங்? நம்ம கிராஃப் இங்க போய் ஸ்டார்ட் ஆச்சு, கரெக்டா? அப்ப இது ஜீரோனா எங்க ஸ்டார்ட் ஆகணும்? வேர் இட் ஹாஸ் டு ஸ்டார்ட். ஜீரோனா வெதர் இட் இஸ்
zero.
அப்படியே ஒய் ஆக்சிஸ்ல வந்துடணும், கரெக்டா சார்? எக்ஸாக்டா ஒய் ஆக்சிஸ்ல வரணும். ஓகே. வாட் இஸ் ஹை ஃபார்வர்ட் கரண்ட்? ஹை ஃபார்வர்ட் கரண்ட் என்னது? இது மாதிரி ஸ்லோவாலாம் இன்க்ரீஸ் ஆகல, அப்படியே சடனா போகுது. ஓகேவா? First assumption, what is zero resistance and closed circuit? What is the meaning of closed circuit? First of all, whether it is a closed circuit,
Power.
whether it is a closed circuit, the first one.
Yes, sir.
Which one is the closed
current.
circuit in this?
Second one, sir.
Second one is the closed circuit. Don't surprise. This is your forward bias condition. This is your reverse bias condition. Now we are, this is your reverse bias. This is your forward bias. Forward bias la enna solranga, en diode or closed switch act agum. Okay, இது எப்படின்றது இங்க பாப்போமா? Yes, check here. Ideal diode model. My diode I will replace as a closed switch. Can anyone tell me about reverse bias la idu enna switch ah irukkanum? Idu
Open.
avladhaan kanna. Idudha ideal model of diode. Please take a screenshot of this one. This symbol implies இது மாதிரி ஸ்கூல் எழுதியிருப்போமா? சிமிலர், அதான் சிமிலர். ஓகேவா? ஆர் அதர்வைஸ் ஈக்குவலன்ட் சர்க்யூட்னா we will put this symbol also. This circuit is equivalent of this under ideal condition. Okay? Yes. ரொம்ப பயந்து கூட சப்ஜெக்ட் எல்லாம் பார்த்து சரியா? இதுக்கு கிராஃப் பிளாட் பண்ணா எப்படி இருக்கும் பார்க்கறதுக்கு முன்னாடி we will see reverse bias. Very simple. Opposite to that, அங்க closed circuit, இங்க open circuit. அங்க zero voltage drop, இங்க high voltage drop. அங்க high forward current, இங்க zero reverse current. அப்ப நம்ம again இது ஒரு கம்பேரிசன் டேபிளுக்குள்ள கொண்டு வந்தா ஈஸியா கொண்டு வந்துடலாம். கரெக்டா? Now this is your model. அங்க high current, high forward current, இங்க zero current. There it is open circuit. This is the closed switch. புரிஞ்சிருச்சா சார்? Please take a screenshot of this one. Yes. Now with this idea, we will draw the graph. If you plot the graph in ideal condition, exactly it will fall in the y-axis. Similarly, in the reverse bias, it will fall in the x-axis. புரிஞ்சிருச்சா சார்? புரிஞ்சிருச்சா? புரிஞ்சிருச்சா? இங்க பாரு, கரண்ட் ஃப்ளோ ஒண்ணுமே இல்லை. இங்க closed circuit current அதிகமா இருக்கு. So closed circuit current அதிகமா இருக்கு. So here, if I connect voltmeter, the potential difference between these two terminal will be zero. Correct, sir? இங்க ஏதாவது voltage drop occurனா தான் எனக்கு difference வரும். Here I don't have any voltage drop. Therefore, I am getting 0 volt. அதனால தான் straight up போயிடுச்சு. But here, it is an open circuit. Do remember one thing. What is the current through the circuit, sir? In the circuit, la current என்னவா இருக்கும்? Can anyone tell me? I is equal to 0. அப்ப இதுல ஒரு டிராப்பும் இருக்காது. நம்ம என்ன இன்புட் வோல்டேஜ் கொடுக்கிறோமோ, the same input voltage available across this terminal. This simulation, we will show it in the multisim simulation. Don't worry. Okay pa? அப்ப switch open இருக்கும்போது இதுல current flow இருக்காது, but voltage higher இருக்கும். அதனால நம்ம வீட்ல இருக்கிற switches நம்ம ஆன் ஆஃப் பண்ணும்போது வெட் ஹேண்டில் ஆப்ரேட் பண்றது நல்லதா, ட்ரை ஹேண்டில் ஆப்ரேட் பண்றது நல்லதா?
Dry.
இப்ப புரியுதா? அப்பா ஏன் கையை தொடச்சிட்டு சுவிட்சை போய் டச் பண்ணுன்னு சொல்றாருன்னு? ஸ்விட்ச் ஆஃப் பண்ணும்போது ஸ்விட்சுக்கு அக்ராஸா யூ வில் ஃபைண்ட் 230 வோல்ட். நீ எங்கேயாவது கொஞ்சம் வெட்டு ஹேண்ட்ல கொண்டு போய் வச்சீங்கன்னா the 230 வோல்ட் will gets discharged over your finger to ground. You will feel heavy shock. Okay va? Yes. We will skip those things. Take down this alone. With this, we will enter into the last topic, capacitance in PN junction diode. I am not going to discuss much over here. Please take only the two types of capacitance available. Before that, let me trigger you on what is capacitance. Capacitance is another. Can anyone tell me? Two conducting plates separated by what? Capacitor. Eppadi form pannalam? This is your capacitor. Am I correct, sir? Am I correct, sir? Two parallel plates separated with the insulating medium. படிச்சிருக்கமா ஸ்கூல்ல?
Yes, sir.
These two are conducting material. In between la irukkiradhu dielectric medium, that may be air or any insulating material. So what is the formula to find the capacitance? So C is equal to A divided by D. படிச்சிருக்கமா sir? Are we studied this formula?
Yes, sir.
It depends upon the permeability of the dielectric medium. This is cross-sectional area of the plate. What is D? Distance between the plates. Padichirkama? This is the one formula. Another formula, C is equal to the amount of charge accumulated in the plate. In the plate, evlo charge accumulate agudhu for a given voltage. C equal to Q by V. Are we studied these two formula in our school days? Or we studied these two formula in our school days? If you remember these two formula, you can find what is diffusion capacitance, what is a transition capacitance. And also, diffusion capacitance will take place in the forward bias condition. Transistor capacitance will happen in the reverse bias condition. Please take a screenshot of this one. Within 2 minutes, we will wind up the session. Don't worry. Note paniyacha, sir? Note paniyacha?
1 minute, sir.
1 minute, 1 minute. Okay. Take a screenshot. It is not possible to draw this diagram immediately. I think you may remember on Tamil proverb, Murpagal Sayin, Pirpagal Tane Vilayum. Correct, Kanna? Okay, okay. Lunch time, I no need to discuss anything other than this. Yes. The forward bias diffusion capacitance very simple. During forward bias, the charges will get accumulate in the region, the depletion region in the task nadakkum. Okay va? Diffusion capacitance அப்படின்றாங்க. அப்ப எங்க நடக்கும்? நம்ம இந்த particular regionல தான் நம்ம பேசிட்டு இருக்கோம். ஓகேவா? சோ அப்ப என்ன ஆகும்னா the amplitude of the input change in amplitude of the forward diode voltage will make to accumulate some charges in the depletion region. And the region la kandupidikra capacitance value da enadhu CD. Can anyone tell me what is the formula to find CD then? CD is equal to what? Change in del. Hello? சரி எல்லாரும் பசி மயக்கத்துல இருக்க ரிசல்ட் காட்டுற எழுதிக்கும் del q divided by del vf. Is it clear, dear students?
Yes, sir.
இது எந்த bias நடக்கும்? Forward bias, reverse bias. Forward bias. Then in reverse bias, the depletion region or width என்னாகும்? Increase ஆயிட்டே போகும். கரெக்டா? இங்க d க்கு பதில் நம்ம என்ன போட்டுருக்கோம்? W. That is nothing but the width of the depletion region. So depletion region width increase ஆக the capacitance effect will get increase. Okay sir? இது ரெண்டு மட்டும் தான் நாம வச்சுக்கணும். இங்க என்ன நாம வச்சுக்கணும்? Whenever I increase the forward voltage, capacitance value will get decrease. Am I correct sir? Am I correct sir? So forward la capacitance value ரொம்ப கம்மியா இருக்கும். Reverse bias la capacitance value will be high. Okay? Please take a screenshot of this one. Please take a screenshot of this one. Here the width is nothing but the depletion region width. நம்ம basic formula la the D in படிச்சிருக்கோம். Okay va? Yes. That's all. The application of diodes. Rectifier means AC to DC conversion. இது நம்ம மாடியூல்ல next title படிக்க போறோம். Therefore I am not going to discuss much here. At least take a screenshot of this one. This is the first application. Then the next application is the clipper. Clipper அப்படினா ரொம்ப simple. It will clip the portion of the waveform. இங்க negative cycle clip பண்ணி உனக்கு அவுட்புட்ல கிடைக்குது. This is your input waveform. This circuit will clip the negative portion. Please find the second diagram and tell me which portion is clipped in the second diagram. Which portion is clipped in the second diagram?
Positive.
Positive. என்ன changes இருக்கு? Diode and resistor configuration மாத்தி இருக்கும். கரெக்ட்டா சார்? Please take a screenshot of this one. இதெல்லாம் அந்த மாடியூல்ஸ் வரும்போது உங்களுக்கு எக்ஸ்பிளைன் பண்றோம். ஓகேவா? The last one is the clamper. Clamp என்னது? ஏதாவது ஒன்று ஹோல்ட் பண்ணி நிக்கணும். இங்க பாருங்க, என்னோட வேவ் ஃபார்ம் இங்க 0 ரெஃபரன்ஸை இது ஷிஃப்ட் பண்ணி மேலே கொண்டு போயிருச்சு. கிளாம்ப் பண்ணியிருக்குதா? Therefore இந்த பர்டிகுலர் சர்க்யூட்ல டயோடு யூஸ் பண்றதுனால it will clamp your output. That's all. Thank you very much. Sorry I took இங்க டயோடு ரிவர்ஸ் பண்றோம், இது நெகட்டிவ்ல கிளாம்ப் பண்ணுது. ஓகேவா? Please take a screenshot of this one. Thank you very much. Do you have any doubt or not captured any slides? Please tell me. I will reappear the same slide. You take a snapshot of this one, then you can leave. இது ரெண்டுக்கும் வேற பேர் இருக்கு, பாசிட்டிவ் கிளிப்பர், நெகட்டிவ் கிளிப்பர். பாசிட்டிவ் அப்படின்னா it will பாசிட்டிவ் கிளாம்பர் அப்படின்னா it will clamp your waveform in the positive quadrant. Negative clamperனா இது நெகட்டிவ்ல clamp பண்ணும். Is it clear, sir? Don't worry.
Yes, sir.
Remember the name and remember the circuit. That's all. Okay. Thank you very much for your
Thank you, sir.
listening. Try to finish the quiz. Try to finish the quiz and all. If you finish the quiz, you will get one thing.